Alright, I'm just going to go over some basic terminology with electricity. Just a real quick background there. Electricity comes from the Greek word for electron, because really electricity is about electrons, moving electrons, things like that. You've most likely been around obviously a lot around electricity your entire lives. But one thing that's really easy to experience or feel is a static electricity. Generally, we don't want you to go stick your fingers in outlets and things like that. That'd be bad. But static electricity, you've probably done this a million times, where if you rub your socks or something like that on carpet and then touch your siblings or your parents or something like that, you give them a little shock. Well, you do that because you can build up a charge simply by rubbing things together. Certain objects are better at accumulating charge than other ones. So static electricity is really about becoming charged, building up a charge of electrons, or a lack of electrons, depending on which kind it is, as a result of doing that. Okay, so just so you're aware, electrical charges can either be positive or negative. And just like most other things, unlike charges attract, so a positive and a negative, those will attract. Like charges repel, so two positive or two negative charges will repel each other. There is a law of conservation of electrical charge, which simply means the same thing as any other conservation law. Conservation of mass was all mass, cannot be created nor destroyed. It only changes forms. All energy cannot be created or destroyed. It only changes forms. Same thing with electrical charge. Okay, the total amount of charge you have at the beginning must always be present at the end. That'll come in a little bit down the line here. A reminder of the differences between insulators and conductors. Insulators are things that don't accumulate charge. Conductors will do it quite easily. Just as a refresher, insulators are things like woods and plastics, and conductors are metals for the most part. I also wanted to talk about inducing a charge, because it's kind of fun to do. Inducing a charge is the act of charging an object without actual physical contact. Now, I've put a website on here. I'll post it on my website when I'm done here. At physicsclassroom.com, under the multimedia section, there's a whole portion on static electricity. And I wanted to show you just real quick what that looks like. If I scroll down here, here's some static electricity. It says charging a single sphere by induction using a negatively charged object. So I'm just going to show you what this looks like. So if you had something that had a negative charge on it, and we'll try a couple of these in class. If you bring it close to a neutral sphere, positive charges draw to one side, negative charges go to the other. And then if somebody touches it, you're essentially called what's called grounding. When you ground it, it gives a path for those charges to leave. So when that person touched the sphere, all those negative charges flowed onto the person, basically, leaving only positive charges behind. So again, you use negative charges, it draws the positive charges towards it, it repels the negative charges. This person comes up here, touches it, removes the negative charges, and then when you pull the negatively charged object away, come on, animation, there you go, you're left with all positive charges. So this is a way to charge something if you needed it to be charged. Okay, let's see, what's this one? A two-sphere system. I'll let you guys watch that one. This is an electroscope, and I have an electroscope. It's a little different than this particular one, but it's the same type of thing. They brought a negative charge close, drawing positive charges up. And this is like a little, well, the one that I have has little pieces of gold foil in here. And as long as it's neutral, they pretty much just stick together. But remember, there's a negative charge there, and we'll have to go back through this one again. But right now, all it's got is all these positive charges all around. So here it comes again. Okay, it's negative, or it's neutral right now. You bring a negative charge to it that draws all the positive charges up. The negative charges stay down here. This person touches it, removes the electrons. All the positive charge remains. And then as soon as they draw the negative charge away out there, all the positive charges spread out, and now this piece and the other pieces will repel each other. Okay, so that's an electroscope. I'd say that it might be good if you guys spend a little time taking a look at those animations and reading them. The two-sphere one's fine. This electrophorus plate, whatever, it's okay. These two, grounding a positively charged electroscope and grounding a negatively charged electroscope, those are good ones to watch too. But I'll let you guys do those on your own time. Okay? All right.